Hello student. Yeah, in the science we already completed with the two chapters. Okay, starting two chapters of the science is completed. The first is the natural resources and the second one is our environment. Now we are going to discuss with the third chapter. Next we are going to discuss with the third chapter of your science, that is atoms and molecules. Okay, now we are going to discuss with the atoms and molecules. Yeah, before going to start with the chapter, we want to know that what are the concepts that present in this chapter. Okay, that what we are going to discuss first, we want to discuss the introduction of this chapter. What are the things that present in this chapter? If you see what are the things that present in this chapter, what are the concepts we are discussing in this chapter means. First, if you see that, first we are going to discuss about the atom. Okay, first we are going to discuss about the concept of the atom. After that, who are the scientists, they given their concept to complete the concept of the atom. Some of the chemists, they given different concepts. Some of them are giving the concept of proton, some of them are giving the concept of electron, like that. All together, all these concepts are together to give the complete structure of the atom. Who are the chemists that given the concept of the atoms are? First, we considered with the Dalton. First, we considered the concept of the Dalton to explain the structure of the atom. The chemist who first explained the structure of atom is Dalton. Therefore, first we are going to discuss with this Dalton postulates. After that, next we are going to discuss with the J.J. Thomson experiments. After, we are going to discuss with the J.J. Thomson experiment. After that, next we are going to discuss with the Goldstone anode. It is similar to the J.J. Thomson experiment only. Next we are going to discuss with the Goldstone anode. After that, we are going to discuss with the Rutherford alpha ray. Rutherford alpha ray. By using the gold, how the Rutherford going to extract the alpha ray. The next, Chadwick discovery. Next, the Bohr's model. These are the important experiments we are going to discuss to study the structure of atoms. What are the important experiments we are going to discuss to study the structure of atoms? Dalton postulates, J.J. Thomson experiment, Goldstone anode, Rutherford alpha ray, and Chadwick discovery, and also the Bohr's model concept. These are the important experiments we are going to study the structure of atoms. After studying all these experiments, now next we are going to discuss with what are nucleons, atomic mass. In the atomic mass, we are going to discuss with what are protons, what are neutrons. In the atomic number. After this, next we are going to discuss with electrons, atomic number, energy levels. Okay, these are the concepts that present in the chapter. Okay, now we are going to discuss with the one by one. First, if you see the structure of atoms, we, the Indian philosophers, okay, the Indian philosopher name called as Kannad, okay, the name called as Kannad, he explained the concept of the atom. Okay, he going to explain the concept of the atom by the name of Paramanu. He is telling the concept by taking the name of Paramanu. How he does this concept means, he taking the one small piece of the rice, he going to divide that piece of the rice. After the some division, the rice is not get divided. Okay, it end up with the one small particular end. Then he concluded that what is Paramanu means, the substance which is not divided further. The substances which are not divided further than that particles. that particles we call it as an paramanu. This is the concept of the Kannada. Okay, he only first give the concept of this paramanu, the atoms. Now we have discovered so many years we completed, we discovered so many things we included to this atom. Now we are going to study that what is atom. Can you anyone tell that what is atom? Can anyone tell that what is atom? What is atom? Atom is the smallest particle. Atom is the smallest particle of a matter. What is atom? Atom is a smallest particle of a matter. Then this called as an atom. What is atom? Atom is a smallest particle of a matter. What is the definition of the atom? Atom is a smallest particle of a matter. This is the definition of the atom. You know the early concept of the atoms, right? By the philosopher of the Kannada. And also the Greek philosophers also, they also give their own concept of the atoms. After the so many years, again the Dalton, okay, the chemist or the scientist who the name of the Dalton, he explained, he gave some of the postulates. He explained and he gave some of the postulates to the atoms. Dalton gives some of the postulates to the atoms. Now we are going to discuss with this some of the postulates of the atoms. What are the important postulates of the atoms? What are the important postulates of the Dalton given to the atom is, the first point is, elements are made up of the very small indivisible particles called as an atom. This is the first postulate. What is the first postulate? Elements are made up of very small elements. How the elements are made means, elements are made up of very small particles. Very small tiny particles. We call that as an atom. Therefore, the definition of the atom was given by exactly by the Dalton. What the Dalton said? Dalton said that the first postulate was told by the Dalton is, the Dalton said that the first postulate is, elements are made up of very small individual particles. Elements are made up of very small individual particles. We call it that as an atom. After that, the second postulate is, all atoms of particles, elements are identical in shape. If you see the shapes of the atoms, almost all the elements have the same shape of atom. That is, the nucleus is present in the center and electrons are revolved around the nucleus. If you see all the atoms having this diagram only, identical shape. Atoms are having the identical shapes. Understood? What is the second postulate? The second postulate is, all atoms of particles, elements are identical in shape and also the mass and the other properties, but differ from the atoms of the other element. If you consider that in your family, I am giving the example for this postulate. Consider that in your family, all the characteristics of your family is similarly equal, right? If you see the characteristics of the family members, you have some similar characters. Height, maybe height, hair, color, like that. You have some similar characters. But if you see some other person, that is your neighbors, if you see the characteristics of your neighbors and your family, it is different, right? That's why this is the second postulate, what he explained. What he explained? All atoms of particles, elements are identical in shape, mass and other properties. They are identical in shape, mass and other properties along themselves, but are different from the atoms of other elements. If you see the other element, the masses are different. This is the second postulate. And what is the third important postulate of this Dalton is, atoms of one element cannot be converted into those of other elements. Consider that you can't convert your family members to the another family, right? You can't convert your own family members to the another family. This is the third postulate. Only the atoms of the one element cannot be converted into those of the other element. Consider example of, you are taking the hydrogen. Okay, you are taking the example as an hydrogen. The family of the hydrogen cannot be converted to the family of the oxygen. This is the third important postulate. What is the third important postulate? The third important postulate of the Dalton is, atoms of one element cannot be converted into those of the other element. This is the important third postulate of the Dalton. After that, the fourth important point of the Dalton postulates are, atoms of an element combine in integral ratio. Atoms of elements combines in integral ratio with those of other elements to form a compound. That means, if the elements are combined, consider that hydrogen is combined with the oxygen. Consider that hydrogen is combining with the oxygen to form water. I am taking the example of water. If hydrogen is combined with the oxygen, it should be in the particular ratio. That means the hydrogen is 2 and oxygen is 1. Right? In the water, if you see the water, the hydrogen is 2 and oxygen is 1. Therefore, it has its particular ratio. That is, the ratio is 2:1. Hydrogen is 2 and oxygen is 1. Therefore, it is 2:1. Therefore, the elements are combined each other to a particular ratio. If you see the carbon dioxide, carbon is 1 and oxygen is 2. Therefore, 1:2. Water, 2:1. Therefore, for the particular reason, the formation of the particular compound by using the element, it has its particular ratio. This is the fourth postulate. What is the fifth postulate? An atom can neither be created nor be destroyed. This is the fifth important characteristics of the Dalton. What is this fifth important characteristics of the Dalton? The atoms are neither be created nor be destroyed. We can't create the atoms, right? If we create the human beings, no, if you are human beings, right? If you create any of the single thing, no. Therefore, you can't create atoms also. Atoms can neither be created nor be destroyed. These are the 5 important postulates of the Dalton. What are the 5 important postulates of the Dalton? Just one time I repeated all the 5. The first one is, elements are made up of very small individual particles. Elements are made up of very small individual particles called atoms. Second one, all atoms of a particular element are identical in shape, mass and other properties, but are different from the atoms of one other element. This is the second one. Third, atoms of one element cannot be converted into those of the other elements. This is the third important postulate of the Dalton. Next, the fourth, the atoms of the element combine in integral ratio with those other elements to form the compound. And the fifth, an atom can neither be created nor be destroyed. This is the next important characteristic, that is the postulates of the Dalton. We explain the 5 important characteristics of the Dalton experiment. This is the 5 important characteristics of the Dalton postulates. Hope you understood each 5 postulates. Okay, that is the important one. Now we are going to discuss with this J.J. Thomson experiment, Goldstein anode experiment, Rutherford alpha ray experiment, Chadwick experiment. All these 4 experiments I will explain through the visual. Okay, I will show you all these 4 experiments in the video. Why means this experiment you understood properly when you see the video. That's why now I am going to explain this 4 experiment by to show you the video. After seeing the video, if you get any doubt from this 4 experiment, you can ask. Okay, this 4 experiment. Now what are the 4 experiment? I said J.J. Thomson experiment, Goldstein anode experiment, Rutherford ray, Chadwick's discovery. This 4 experiment I will show you in the video. Okay, you just go through one time the video. After that we will explain this one more time. Okay, the Dalton postulates is over. This 4 experiments already we saw. Now the next concept is the Bohr's model. Who is this Bohr? Okay, what is this his model? Okay, the Bohr is a chemist who explained the concept of the atoms properly without any failure. Some of this experiment and some of this experiment having the failures. Okay, but Bohr cleared all the fallback of this experiment was cleared by the Bohr. And as Bohr also given the 4 important postulates. Bohr also given the 4 important postulates. And also Bohr explains that if you see this is the nucleus, center nucleus. Around the nucleus all the electrons are revolving. It came in the center, it should be in the center. Okay, this is the nucleus, the center part we called as a nucleus. In the nucleus, what are the things that present in the nucleus means protons and neutrons. In the nucleus first side is written, right? In the nucleus, what are the things that present? In the nucleus, we have protons and neutrons. What are these protons and what are these neutrons means? Protons are positively charged particles that present in the center of the nucleus. What are protons? Protons are the substance which are having the positive charge. Protons are positively. Pro represent positive. Protons are positively charged. And neutrons are neutrally charged. For protons, if you have the plus charge, for the neutron, you don't have any of the charges. Neutrons are neutrally charged. Protons are positively charged. Neutrons are neutrally charged. And remaining that this circle, the orbital, is covered by the electrons. This is covered by electrons. Electrons are revolving around the nucleus in the respective orbitals. You know that for the sun, the nine planets are revolving, right, in their respective orbitals. Like that, here also the nucleus is surrounded by some of the electrons. Electrons are revolving around the nucleus. Understood? All the concept was explained by the Bohr. And also Bohr tell the concept of the orbitals of K, L, M, N energy levels. This concept. The concept of energy level also was explained by the Bohr. He called this first orbital as a K shell. He called first orbital as a K shell and second orbital as a L shell and third orbital as a M shell. K, L, M shells. The K, L, M, N shells. Then the next fourth one he called as an N. This K, L, M, N orbital concept was also explained by the Bohr. The energy levels. Okay, the energy levels are also explained by the Bohr. Now, therefore, we are going to see that what are those Bohr's important postulates. What are those Bohr's important concept of postulates? Now we will discuss the important postulates of the Bohr. Listen here. The postulate you didn't want to write wrong. What are the postulates they given? You want to write it as it is. No one word should be added to that postulate, or no one word should be removed from that postulate. That's why the postulate should be written properly. Understood? Only the two important postulates you want to write. One is of the Dalton postulate and another one is the Bohr's postulate. One you want to study about the Dalton and one thing you want to study about the Bohr's. What is that first Bohr's important postulate means? Electrons revolve around the nucleus only in certain permissible circular orbits. We call it as in shells. The first, what is the concept I explained now? This is the first postulate of the Bohr. He explained that all the electrons are revolved. All the electrons are revolved in their particular orbit. All the electrons are revolved around the particular orbit. That orbit is given the name as K, L, M and shells. The first shell we call it as an K shell, second L, M and N. This is how the K element shells will arise. This is the first postulate of the Bohr. Next, the second postulate. Electrons in each shells have been associated with definite amount of energy. Electrons in a higher shell have more energy than those near to the nucleus. Okay, the next important postulate is the electrons in each shell. This electrons, okay, the electrons in the each shell have associated with some amount of energy. The electrons are present in the shells have the definite amount of energy. If it is present in the higher level, it has the amount of energy is more. If it is present in the lower level, the amount of energy is less. That means if the electrons is present near to the nucleus, then it has the higher energy. If the electron is present near to the nucleus, then it has the higher energy. When it is moved away from the nucleus to the second, third like this, if it is moved away from the nucleus, it has the less energy. This is the second important postulate of the Bohr. Next, third, the energy of an electron remains constant so long as it revolves in its own shell. The shell also represents the energy level. If you see the energy levels, the shells, okay, if you see this shell, it also, I said that it has its own energy level. Therefore, it should be present in energy level only. The electrons that should be present in its own energy level. It cannot be jumped to the next energy level, or it cannot be jumped the electron into K to L, L to M like that. Understood? These are the three important postulates of the Bohr. What are the three important postulates of the Bohr? The electron should be present in the K element shells. The nucleus is present in the center of the atom, and the energy level should be present. The highest energy level where the electrons and nucleus are closer. The lower energy level means where the nucleus and electrons of the outer shell, and the electron should be present in their respective energy levels. These are the concept of Bohr's model of Bohr's postulates. Okay, we completed all those things, right? We completed this concept. This concept we completed. We also completed with this energy level. Now, this nucleus concept is also completed. What are nucleus? In the nucleus, what are the things that present? Protons and neutrons. If protons and neutrons togetherly called as a nucleus. Then what is this atomic number? Atomic mass? What is the definition of atomic mass? It is the sum of protons and neutrons. What is atomic mass? Atomic mass is defined as the sum of the protons and neutrons. Protons are positively charged. Neutrons are neutrally charged. The sum of protons and neutrons, togetherly called as an atomic mass. This atomic mass, the sum of protons and neutrons, togetherly called as an atomic mass. After that, next we are going to discuss with the atomic number. What is this atomic number? Atomic number, it is defined as the number of protons present in the nucleus. Only the amount of protons that present in the nucleus. The total number of protons that present in the nucleus we call it as an atomic number. And it is represented by Z. And it is represented by the Z. What is atomic number? It is defined as the proton present in the nucleus. Protons present in the nucleus we call it as an atomic number. Here the X is considered as the element. X is considered as the element. And Z, you know that it is the atomic number. Then what is this A indicates? A indicates the atomic mass. X is the element, Z is the atomic mass, and A is the mass. Understood? Therefore, the atomic number is, what is atomic number? It is defined as the number of protons present in the nucleus. Number of protons present in the nucleus we called as an atomic number. And it is represented by the Z. The last concept of this chapter. Okay, we completed with this electrons. What is this electrons? The atomic number complete. What is this electrons? Electrons are negatively charged particles. What are electrons? Electrons are negatively charged particles that present in the atom. Electrons are negatively charged particles that present in the atom. We call it as an electron. And we already know the atomic number, we know the energy level. And the last concept of this chapter is isotopes. What are isotopes? This is the last concept of this chapter. What are isotopes? The atoms having the same atomic number. Therefore, it having the same atomic number. It having the same atomic number but different in the mass number. I will give one of the example for that. Okay, see, what are isotopes? Atoms having the same atomic number. I am taking for the carbon. Okay, for the carbon, the atomic number is 6. For the carbon, the atomic number is 6. Therefore, the atoms having the same atomic number but different in the mass number. See, this is 12, see 14. Therefore, what are isotopes? Atoms having the same atomic number but different in the mass number. Then this type of compounds are known as isotopes. What are isotopes? The compounds having the same atomic number but different in the mass number. These are known as the isotopes. Hope you have understood every concept. I explained every concept that present in the chapter. But this 4 experiment we will see visually. After that, if you have any doubt in that experiment, we will discuss in the class only. I hope you understand all the concept of this chapter. That's right. Okay. Thank you. Thank you, everyone. We will start the next chapter in the next class. Thank you. Bye.